Hello students, I am Nilanjana Sanyal. Welcome you all to my channel Learners Online Math Classes. Our today's topic is solving logarithmic equations containing a single logarithm. From today we are starting with the solving of logarithmic equations, and in our today's session there will be a single logarithm in each equation, and we have to get the value of the variable present in the equations without the help of a calculator. There will be 3 questions solved in this session, and there will be the case of extraneous solution as well. What is an extraneous solution? It means an extra solution. We will be getting different values for x or whatever variable is present, and not all definitely we will be having more than one solution, and not all the solutions will be included or can be included in the final answer. Okay, that is the case of an extraneous solution. So I definitely be asking you to stay tuned till the end so that you understand the process completely. And without any further delay, let us start with today's session. First of all, let us look at the rules. There is one single rule set: convert to the corresponding exponential equation and solve. So the given logarithmic equation has to first be converted to an exponential equation, and then we have to solve that exponential equation by making the base the same for both the sides or making the parts the same of both the sides, whichever is suitable. Okay. So we start with the questions. Question number 1. Solve log of 2x minus 1 to the base 5 equal to 3. This is a logarithmic equation. We have to convert it to its corresponding exponential equation. Base b is 5, argument a is 2x minus 1, and the product p is 3. So when this is BAP, and when we change it to its corresponding exponential equation, it will be BPA. B stands for the base, P becomes the power, and A argument becomes the answer. So it will be 5 raised to the power of 3 equal to 2x minus 1. And we have to find the value of x. So 5 raised to the power of 3 is 125. So 2x minus 1 equal to 125, and if we add 1 plus 1 to both the sides, we get 2x equal to 126, or x equal to 63. On dividing both the sides by 2, we get the x value as 63. Okay. So we have solved our very first logarithmic equation, which contained a single logarithm, and we have found the value of x to be equal to 63. We may check whether the value of x that we have found can be taken or not. 2 times x is 2 times 63, which will be equal to 126, and 126 minus 1 is 125. And we know the restriction for being an argument of a logarithm is it should be a positive integer. It cannot be a negative integer, it cannot be equal to 0, it should be a positive integer. And 126 minus 1, that is 125, is indeed a positive integer, so we may take this value. This is our final answer, is x is equal to 63. Okay. Coming to question number 2. Solve 2 times log of x to the base 27 is equal to 4 over 3. Now this question, I have solved it in 2 ways. I'll be showing you both the ways. So first method, first, for the first method, I have divided both the sides by 2, because we are having 2 over here and this is 4, so we can divide this by 2. So after dividing both sides by 2, we get log of x to the base 27 equal to 4 over 3 divided by 2 is 2 over 3. And next we convert this logarithmic equation to its corresponding exponential form. It becomes 27 to the power of 2 over 3 is equal to x. We usually write x on the left side, so I have written x equal to 27 raised to the power of 2 over 3. And we have to simplify this part, so 27 can be written as 3 to the power of 3 because we are having 3 in the denominator for the power. So this is 3 to the power of 3 whole raised to the power of 2 over 3, and this 3 and this 3, they may get cancelled, and we have x equal to 3 to the power of 2 or x equal to 9. So x is the argument for this log term, x equal to 9, a positive integer. We can take this value of x, that is 9. This is the final answer for this question 2. So let us try to solve this same logarithmic equation with a different method. Okay. So this time we are not dividing both sides by 2. Rather, we are taking this 2 from the coefficient place and making it the power of the argument. So it becomes log of x squared to the base 27 equal to 4 over 3. And next what we do? We do the same thing. We will be getting the exponential equation. It will be x squared equal to 27 to the power of 4 over 3. And again we will be writing 27 as 3 to the power of 3 whole raised to the power of 4 over 3, and these two 3's will get cancelled. And this time we have 3 to the power of 4, which is equal to 81. So x squared is equal to 81. But we have to get the value of x, so we take the square root of both the sides and we get the x value as plus minus 9. But can we take plus 9 and minus 9, both the values of x? See, we cannot, we have tested the plus 9 part in this method. Plus 9 can be taken, but what about minus 9? We cannot take this negative 9 because this is log of x. X is the argument. An argument of a logarithm cannot be a negative number, so we cannot take this negative 9. That is the extraneous solution. We are having two values of x. Out of these two values, only one value can be taken, and the other has to be rejected. Okay, that is known as the extraneous solution, and for logarithmic equation, it is totally compulsory to check whatever value you get, you substitute that value in the given logarithmic equation to see whether you can take that value as your final answer or not. Okay, it is compulsory, totally mandatory for solving any logarithmic equation. Okay, so the answer is x equals positive 9. Coming to question number 3. Solve log of x to the power of 2 minus x minus 5 equal to 0. The base is of course equal to 10. And we convert it to its exponential form. It becomes x squared minus x minus 5 is equal to 10 raised to the power of 0 or equal to 1. Anything raised to the power of 0 is equal to 1. So x squared minus x minus 5 is equal to 1. And how do we solve quadratic equations? We bring all the terms to one side of the equal to sign and make the other sign to be equal to 0. We bring all the terms means in this case we will be subtracting 1 from both the sides. So the right hand side becomes 1 minus 1, that is 0, and the left side will be containing negative 5 and negative 1. So it will be x squared minus x minus 6 is equal to 0. Then we may factorize this expression on the left hand side and it becomes x minus 3 times x plus 2 equal to 0. From where we get the x values as x equals positive 3 or x equals negative 2. Again we are having multiple values of x, but can we take both the values? We have to check. First of all, let us take x equals positive 3 and we substitute in this expression. X squared, positive 3 whole square is 9. 9 minus 3 is 6. 6 minus 5 is 1. And we know log of 1 to any base is equal to 0. So the equation is getting satisfied. Therefore, x equal to 3 can be taken as our final answer. What about x equals negative 2? Negative 2 whole square is positive 4. And this is negative x. Positive x equal to negative 2. So negative x is negative of negative 2, which is positive 2. So 4 plus 2 is 6. 6 minus 5 is 1. And log of 1 is 0. So in this case, even though we are having multiple solutions, it is not always true that whenever you have multiple solutions, you have to reject one of them. You may take both of them depending on what is the question. In our previous case, in answer 2b, we had to reject x equals negative 9. But over here, we are seeing we can take both values of x. So the final answer is x equals positive 3 or x equals negative 2. Okay? So whenever you have multiple value, do not assume that you have to reject one of them. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.